outside, let's say, the planet Earth, if you think of the mass of the planet and the distance from the center, right, you can define at any point what the acceleration will be. Right? The acceleration is simply g times the mass of the Earth divided by r squared, the distance from the center. And at any point in space near the Earth, you can define what will be the acceleration at that point. You cannot do that, for example, with an electric charge. With an electrical charge, the force will be k q1 q2 over r squared. The acceleration will be this over m. The acceleration is that over m. Whichever charges you use will have a different acceleration, because you can't cancel one out of it. You can't cancel the mass out. So gravity is unique in that all particles follow the same acceleration, which means that these two masses are the same. And as a result, you can define a gravitational acceleration field, which means that if you think about it, the gravitational acceleration is a property of the space around the Earth, or around whatever it is that's doing the traveling. It's not a property so much of the interaction of the particle that's falling towards the Earth with the Earth. Because whatever particle would be there would follow the same acceleration. So if there's an acceleration field, if at every point in space we can define an acceleration, just gm, mass of the Earth, over r squared, irrespective of which particle you put there, that's the acceleration that will be there. That means that that acceleration is, in a sense, a property of the space around the Earth. It's not a property of the particle, because whichever thing you put there will come with that acceleration. Okay? So that gives us a hint that gravity and this relationship, this unexpected relationship between inertial mass and gravitational mass, gives us a hint that gravity is somehow related to something very fundamental about mass. Because inertia, the resistance of motion, is certainly something very fundamental to mass. And something that has to do with space. Okay? It's kind of, in space, there's a field that tells how anything put there will accelerate. Okay? So this model says that if I stick a particle, it'll accelerate. What will happen to two particles of different masses? Will they accelerate the same or different? The same. Why the same? Okay, anybody else? I didn't say anything about masses here. It doesn't, who cares what the mass is? Who cares what color eyes it has? I mean, it's irrelevant. We don't say that there's a force on it. We just say, well, of course, this is what happens because what else do you expect should happen? So we don't need to postulate a force. Gravity is exactly a perfect candidate for this kind of a model. Instead of talking about a theory in which matter energy gives rise to gravitational force that pulls things towards it, we can throw out that whole concept, that whole idea, and just talk about matter energy giving rise to